Hello everyone, so today we're going to look at the Geeks for Geeks problem of the day, which is sum of bit differences. So in this question we are given an array of integers which have n elements, and then we're supposed to look at the differences in bits between all pairs of elements in the array. So if in the same position of between two pairs we're the bits are different. So one, supposing the zeroth bit is 1, and for the other number the zeroth bit is 0, then that would be a bit difference, and then we're supposed to count all of the bit differences. So let's look at one example. So suppose our array was 1 and 2. So the bitwise representation of 1 is 0, 1, and for 2 it is 1, 0. So if we look at the pair 1, 2, in this position the bits are different, and also in this position the bits are different. So the count would be 2. Similarly, 2, 1, the count would remain the same, which would be 2, and the answer is 2 plus 2, 4. So the answer for this array would be 4, right? So the brute force solution would be, we are given the integers a1, a2 up to an, and then we could look at all the pairs of numbers, right? Look at their binary representation, count all the positions in which the bits are different, and then add them up, right? But this solution would be an O of n square solution, which would give us TLE, right? So we can't brute force it. So instead, what are we supposed to do? So instead, what we can do is, let's look at one example, 1, 3, and 5, right? And the binary representation of 1 would be 0, 0, 1, 3 would be 0, 1, 1, and 5 would be 1, 0, 1. So what we can do is, instead of looking at individual pairs and then counting the bit differences, we could look at the bit positions. So this would be the 0th bit position, the first bit, the second bit, right? And then what we can do is count the number of ones in these positions. So for example, in this example, in the 0th bit there are 3 ones. Okay, the count of 1 is 3. So since there are n equals to 3 numbers, obviously the count of zeros would be 0. Okay, so we could say that we could say that the number of pairs which we get, such that the number the bit differences is equals to 0, obviously, because in this position none of the bits are different. So for example, if we look at the first position in this example, the count of 1 is 1 and the count of 0 is 2. Okay, so the number of pairs we can make, so the number of pairs we can make such that in the first position the bits are different is equals to 2. How? It would be C1 times C0. So basically the number of pairs we can make such that the bits are different in the first position. Okay, only the first position. It would be n times n, where n is the number of, let me just take the same variable. It would be C1 times C0. So the number of ones times the number of zeros in that position, in the first position. So how many in the first position the answer would be 2, okay, and in this one, in the 0th position, the answer would be 0 because all of them are 1, so there is no bit differences. In the second position, we have C0 equals to 2 and C1 equals to 1. So obviously the answer is C0 times C1 equals to 2 for second position. Okay, so what would the answer be? The answer would be we have to basically just sum up all the pairs, like the C0 times C1 for all the individual positions. So here it would be 2 plus 2 plus 0, and then multiply it by 2 because if 1, 3 and 3, 1 are taken differently, so we have to basically for this we calculated like all the a1 times an, but if we multiply by 2 we also consider a1 a1, right, like that. So yeah, how would we code all of this up? So first we're going to loop over all of the positions, right? Okay, and then we're going to loop over all the individual numbers. So how do we find the individual? So I'm just going to count the number of ones, okay, because obviously the number of zeros would be n minus c1. So so how do we know that in this position it's a 1 or a 0? If we take the element and it with this, we will know if in this position the jth element has a bit 1 or a bit 0. So if this is equals to 1, it will go into this if statement, and then we can do c1 plus plus. Okay, and so the answer would be answer plus c1 times n minus c1, which is the number of zeros, the count of number of zeros in that position. So this is the code for it. We can, it's whatever I've explained right here. Okay, let me just submit it. Okay, thank you.